Here we're going to look at how we can work out the shape of a molecule given its molecular formula. We're going to look at about 5 examples. The first example we'll look at is ASH3. The first thing we would need to do is identify the central atom, that is where we've only got one of them, and in this case arsenic then is my central atom. We identify the group that arsenic is in, which is group 5, and because it's in group 5 it will have then 5 electrons available for bonding. Of them 5 electrons, we need to think how many of them are involved in forming bonding pairs. And that is equal to the number of atoms attached to this central atom. So this number here would give me the number of bonding pairs of electrons. The number of lone pairs or non-bonding pairs is going to be the number of electrons available minus the number of bonding pairs divided by 2. Because these non-bonding electrons go around in pairs. So it'd be 5 minus 3 divided by 2, and that gives me 1 lone pair. Now, you should be able to recall the name of the shape. You need to be able to draw the shape and state any bond angles once you know the number of bonding pairs and lone pairs in a molecule. In this example, we've got 3 bonding pairs and 1 lone pair, and that gives me a trigonal pyramidal, sometimes just shortened to pyramidal shape. Bond angle of 107, and again, you should be able to draw that molecule based on previous videos. The next example we look at is a molecular ion with a positive charge. First thing we do again is identify the central atom. It's phosphorus, and that is in group 5. Now, if this was a neutral molecule, we would say then 5 electrons are available for bonding. However, we've now got a molecular ion, so we've got a positive charge here. And if we get a positive charge, we subtract the number of electrons, and phosphorus would usually have 5 electrons available for bonding. Because the molecule's got a plus charge, we take 1 away. And that means actually the phosphorus has got 4 electrons available for bonding. How many of them 4 electrons are involved in forming bonding pairs? Well, it's equal to the number of atoms attached to the central atom, which is 4. That tells me I've got 4 bonding pairs. The number of lone pairs is 4 minus 4 divided by 2. And that obviously gives me no lone pairs. And we should be able to recite the name of the shape if you've got 4 bonding pairs and no lone pairs. And that name is tetrahedral. And you should be able to draw this and state the bond angle. The bond angle, remember, is 109.5. The third example we're going to look at is of a Cl3 plus ion. Now, what we've got there is a molecular ion with 3 chlorines. One of those chlorines then must be the central atom, and therefore the group number of the central atom is going to be 7. Because I've got a 1 plus charge, the number of electrons available for bonding is going to be 7 minus 1, which is equal to 6. How many of those 6 electrons are involved in forming bonding pairs? That's the number of atoms attached to the central atom. And if one of those 3 chlorines is the central atom, then there must be 2 chlorines attached to that central atom, which would mean I've got 2 bonding pairs. Number of lone pairs then is going to be 6 minus 2 divided by 2, which gives me 2 lone pairs. And again, you should be able to recite the name of the shape if you've got 2 bonding pairs and 2 lone pairs, and the molecule is the same as water, same shape as water, is bent. with a bond angle of 104.5. Let's now have a look at a negative molecular ion, and we're going to have a look at an NH2 minus ion. Now, again, we identify the central atom, and we can do so in this case, and we've got a nitrogen, and that is in group 5. Now, that means we've got 5 electrons available for bonding, but we've got a negative charge, and it's a 1 minus charge, so we add 1 electron to them 5, and that gives me 6 electrons available for bonding. How many of those 6 electrons are involved in forming bonding pairs? Well, there is 2. That gives me then 2 bonding pairs. The number of lone pairs is 6 minus 2. Remember, it's this number minus this number divided by 2. And that gives me 2 lone pairs. So if you've got 2 bonding pairs, 2 lone pairs, we're going to have the same example as we had previously, and that is going to be a bent shape with bond angles of 104.5. So that's there, a quick look at how we can work out the shape of a molecule given its molecular formula. Remember, if you've got a positive ion, you remove electrons. If you've got, for example, 2 plus ion, you'd minus 2. If you've got a negative ion, you add electrons. If you've got a 2 minus charge, you'd add 2 electrons, and so on. So that there is how we can work out the shape of a molecule given its molecular formula.